Alright, so in this video we're going to look at how to create a trellis-like screen. It's not going to be like your traditional one, or that's more like an arbor, but it's going to have a lot of kind of dynamic uh, conditions to it, right? The idea is that you want it to cover some type of pathway. That's the whole purpose of it. So we'll start off just having a center line that's going to denote what our path is going to look like. And again, you'll see that a lot of this is kind of building off of the videos for different type of pathways. So there is going to be some repetition to this, but it's good always to kind of um, be somewhat repetitive in some of these processes. So again, I'm going to take this center line and give it some variation in widths. So first thing I want to do is go to the curve, divide it by a certain number of points. Start off with something like 15. And in order to give it that width, I need to know the frame. So I'll use the horizontal frame. So that way I know that I'm just going to use the Y, or the screen axis, to dictate the width. So I can now go to vector, deconstruct these frames, and use the Y to give it those variations. And again, I want it to be slightly different in some areas, so I'll use the curve line SDL. So the start is these points. Turn some of this off so you can see a little bit better. The direction, so again, that's the Y. And then I want these to be, I don't know, let's start off with something like 5, maybe a little bit less on one side, but maybe on the other side I give it some, like I said, variation. So I'll use the sets to create a range of values based off of the number of points. Right, so 16 and 16, we're good there. Parameters, input, graph mapper. And again, I'm just gonna create something like the Gaussian one for now. I want it to maybe start off with the minimum length of, again, 4, just like how I have it for the other one. But then give the Y, maybe it goes out to something closer to 8. Again, I can always control these, so I'm not too worried about those presets. So I also want to use this one in the other direction. So I want to make sure to reverse that. So I'll go to vector, vector, reverse. Right? And now I can use this to give it that kind of variation in length. So you can always kind of really exaggerate it in some of those areas and dictate where I want that to be. Alright, so it's made something like that. Alright, so there's that. I can join these curves now. I don't even need to see this. And now I can go ahead and I don't even have, like, I can loft it just so I can see, like, have a physical path there. Right? So here's that. That's what the actual footprint looks like. But in order to get this trellis to work, I actually want to just stick with these points, or these curves, and get their points from that. So I'm going to go to curve now and find their start and end points. So I can turn this off because I think we'll get a better idea what that looks like. And so now from here, I can actually begin to create new edge curves. So I'm going to use the interpolated one for both sides. So there's that side. And here's the side. And the reason I'm doing it this way is because maybe I want there to be either more or less points than what I use to create them. So from here now, it's going to be important that we use the same number for both of these curves, but again, we can dictate how dense we want it to be. So again, I'm just going to divide these by certain designation of points or numbers. So again, just so that they're always both the same. All right. So from these, we're going to basically treat these as like the post for our trellis. So I can create again a line SDL. Direction is the Z, which it's already default to, and so these are the backends points. So I'm going to have them assume that I'm looking to the left in this case. So I want these to be slightly smaller, so maybe their heights are closer to 9. Versus the other side has points closer to 12, where they're slightly higher, right? So there's that. But again, we can have variation to these lengths too. I always like to use the graph mapper to kind of give myself a little more flexibility for those. So let me give myself a little more room here. You'll see that in basically what I can do from here, I'll just kind of jump a little ahead. From these new vertical lines I just created, I can use the point on curve to basically find their high points. Now from here I can just create a line from point A, point B to create those cross beams. Right, so I just want to do this to give you a little kind of visual of what this starts to look like. If I want them to, again, kind of be maybe slightly below those in some areas, you can kind of do it like that as well. You have that ability now to kind of determine some of those things, but I'm just going to keep them at that point for now. And again, maybe they aren't so uniform in height in all directions. So what I might want to start to do is, again, mess with this length. So I'm going to, again, use the sets, range. Again, I'm going to use the same amount. So 13 values, 13 points. Parameters, input, graph mapper. I'll just give myself a little more room here. And I'll, in this case, maybe I use something like the sine curve. And again, I want the heights to still maintain between that initial like 9, but again, I want to have some variation. So maybe I change these values to be between 9 and 11. Let's have a little more fun. Let's actually do this 9 and 12. I'll show you why. And this determines how many are going to be in those kind of heights. So we can start to see how many times it's starting to kind of, if I turn this off, I can maybe see it a little bit better for that side. Right, and I want to basically do the same thing for the other, for the relatively higher side over here. But again, maybe in this case, I want it to be 10 and 14. So sometimes maybe the backside is slightly higher because maybe the 10 on this one matches with a 12 on that side. Right, but and I can even change like which ones are which, right? So maybe there's just one high point for that one. Now I can start to see in some cases maybe it gets close. Yeah, there's some areas where the one side is slightly higher than the other, right? So right there and there, which kind of makes it a little more, again, dynamic in that case. Okay, so we're starting to get some pretty fun results from this. Let's turn that off. And I mean, what you could do, even just from now, you could just go ahead and loft these curves together to create a solid surface on top. Right now we can kind of see this cool ribbon-like top to it. So that's one option. I'll keep that there, just turn it off. If you want those cross beams, we can now take these curves and divide them by a number of points. So we can basically determine how dense we want it. Let's do something like 4 less than 16, right? I don't know if I want too many to be there. So if I were to just create a either interpolated or polyline curve from these, it's just gonna basically replicate those lines. So in order to fix that, I need to go to Sets, Tree, and flip the matrix. So now they'll actually act as those cross beams. And if I want them to be less kind of soft, I could always, or less curves, I can use the polyline curve instead. It's kind of up to you in terms of the overall aesthetics that you want. So this has a little bit more of a rigid shape versus the other one's a little more smooth and organic. Again, it's kind of up to you, but now you have the ability to determine how dense you want that to be, right? So if you really want it to be kind of like a screen, you want to have more points. But we don't want to just be doing this with curves. We want there to start to be some volume as well. So there's obviously the post that we can start. So I can do, I can create a rectangle. Again, it could be a rectangle, it could be a circle. It's really kind of up to you. It could be any shape. It could be a star, even if you want. So the point for these are going to be here, right? I want to, actually in this case, I do want them to be nice and orientated. So again, I've got that curve. Here's the points, there's the lowercase t, so I can actually create horizontal frames from that. All right, so now they actually are perpendicular or tangent to that, so that's actually our plane. So if I turn that off now, I'll see that they actually start to follow it instead of just being a standard orientation. And again, if I want these to be nice and square, I can just use the domain for both the X and the Y. And generally, you probably want these to be on center, so I'll just do 0.15. Again, it's going to go in both directions, in the positive and the negative, so I'm going to do expression for the A. Oops. And do negative x to give it that negative direction. Now I can start to see how that works. So maybe these are slightly thicker. All right, so there's my rectangle. I can now extrude these. Can probably even actually use the, let's try even just using the sweep one, since I've got the rail curve, which is this one, and then the cross section is this one. Nope, it doesn't like it. I guess it likes to actually be a tangent. So anyways, I've got the length there, so I can just extrude it that way. So there's the B rep, here's the distance. Regardless, we don't have to do anything extra. Oops, we just have to add the Z value for the direction, right? And there we go. So there's our lengths for those. Again, what's nice, I can just let's see which ones. I can keep this one and just copy and paste it for this one up here. So again, I'm using this as my new curve. This is the new t values. This is the line, which has the length. All right, so there we go. This is all just using the same domain. So it's, again, getting a little messy in here. So let's go ahead and move some of these guys over. I can keep this one here. So this is kind of our post area. This is our, let's even do it like this. So here's the, again, beams that go across it. So we'll, again, want to make sure that we have the actual correct orientation for these so that they actually are perpendicular to it. So what's cool is I can just do curve, point on curve. Doesn't really matter as long as it's either at the start or the end. It's probably best just to start with have it at the start. Do the curve closest point to find that frame for it. Again, we want it to be perpendicular in this case, right? And now this becomes our new rectangle, which, again, I can keep it consistent with the post, right? Probably want those to be the same dimension. We'll just use this as my new. Well, let's keep giving ourselves more and more room here. And it's probably going to be a little hard to see, but now I can, again, extrude these curves. Here's our little outlier lofted surface. Direction, so I've got the frame, so vector, deconstruct it to get the z value, and use the amplitude to determine how far you want it to be. And that is going to be whatever the length of these are, so you can just go to curve, length, and that's my amplitude for these extrusions. There we go. The next thing we want to do now is create those cross beams, right? So again, I got the P lines. And let's, again, just, this one's a little more tricky since they're all going to have different directions. So we basically want it to kind of pipe, but we can't use the extrude, so let's try. Okay, so we can extrude curves and surfaces along a curve, so let's just do that. Right, I forgot about that one. So there's the B rep. Again, we want to create again another rectangle. This one probably is going to have an even smaller value, so let's just go ahead and create a new one. We want to, again, make sure that we do our, let's see, did these already have their parameters? Yeah, so we could actually go ahead and flip the parameters as well to get our perpendicular frames. Here's the curves that are creating those, I suppose. Oh, so what happens if we don't flip it? Yeah, no, we still want to use the flipped values, except now we want them to go the other direction. Ooh, I wonder if I could do it this way. Is that gonna... Nope, it's not gonna like it that way. So let us undo this. Again, it's just trying to take a shortcut and it's not letting me. It's calling me out on that. So just have to, again, we're gonna take these ones, do the point on curve, closest point, to get that parameter. And again, we're gonna do it perpendicular, curve, lowercase t, right? So they're all just starting out there. Next thing now is now I can finally extrude these, or finally assign this rectangle to it. Oops. And then, again, I don't like to have to use too many of the same things, so I'm going to use the domain and slider here and just copy and paste it. Make these slightly smaller. Right, so maybe have them a little bit thicker. Right, and now I can, as it's saying, profile curve, and then the P-line curve. And there we go. So yeah, we can obviously either make them slightly thicker. You can always add more. Obviously, the wider it gets, it's using the same number, so it is going to start to open up a little bit. But yeah, I mean, for the most part, it's being pretty responsive to this, and we have the, again, kind of flexibility with, again, this is kind of just giving it that volume and shape. If I want, I can even still kind of apply a different screen just to kind of give it that additional covering. But the terms of the shape and everything, that's mostly coming out of here. So I can continue to add maybe more of these signs, so it can be a lot more wavy. Right, maybe there's, these are slightly thinner. Maybe there's less. So those ones are being determined here. All right, so again, you have a lot of flexibility and variation to this. So I'm going to do one more thing. So these are, again, very uniform. Let's try to make them more randomized, kind of like maybe it kind of has this bird nest kind of quality to it. So that all gets affected here, where I'm just dividing them all uniformly. So instead of this, I'll actually keep this part of it. I'm just going to basically take these cross curves, right? These are the ones that are going across or for the beams. And I'm just going to go ahead and go to vector and populate them with somewhere between, like, let's try 5 and 30. Again, we don't want to get too crazy with it. So there's the number to add. I just want to do this because else it's going to give them all 100 points, and that might just overwhelm it a little too much. So let's zoom into here, and I'm going to turn this off. Turn both this off as well as our beams for now, just so we can see it a little bit better, right? So I can see that again, it does randomize it, but each one is getting the same kind of random pattern. So we actually want to give them all unique patterns. So in order to do that, if I know that I've got 13, so that's all being dictated, well, we can actually just use the length to create a bunch of different random seed values for each one. So let's go to sets, create random seed values. So domain between, I don't know, 0 and 50. So we have a nice wide range. How many random values do we want? We can again use however many lines we're using, so they're all unique. So 13, so that way if we add or reduce, it'll all respond to it. And then now we can see that we get these decimal values. I'm going to right click just to make them solid integer numbers. So these are basically going to act as the random seeding. In order for it to work, we need to graft both our lines and our seed values. I'm going to plug that into there. So now we can see that they all are given their own unique kind of randomization. So it's exactly what we want to do. So now from these points, we're basically now kind of following this process to create some polylines. So let me just make sure that we've got that in the right order, or if we have to flip it still. So let's just curve joints. Yep, we need to. So basically from here on out, we're repeating this process. So I'm going to do copy and paste so we can see both options. Now when I turn this on, we start to see this kind of more randomization. So maybe I want there to be more, to be a little more dense, so that's all coming into here where there's 5. So I can kind of keep populating this till I get the results I was hoping for, right? And if I want to, again, kind of even randomize my random, I can change 15 and change this seed so that I get all sorts of different kind of arrangements and configurations of these trellises, right? So again, just gives you that dynamic capability to create different forms and screening options.